Okay, let's get started. Advanced 3D modeling and rendering. That's the topic for today, 11th week. So let's quickly look at where we are. Next week, midterm exam, okay? As you may know, in our class website, CAD&graphics2 2015, for the midterm exam, you can find out entire lecture slides in, of course, in this course, lecture slide page. Also, I just uploaded midterm exam sample questions, okay? So this one is an example. But I think you already experienced the midterm exam, so anyway, based upon these midterm exam questions, you can review what's going to be your midterm exam next week, okay? Of course, material is going to be from lecture slide and my oral presentations and partially from the lab exercise. But anyway, mostly theory oriented course material. So anyway, for the final project, we are going to deal with the final project subject, the issues, or your own content, whatever it is. I told you before about the midterm exam, final project. So we're going to quickly review again about the final project. But anyway, today, the topic is something advanced modeling and rendering. So from this week, we're going to deal with both geometric modeling and rendering issues, okay? So entire lab exercises require some mental ray-based rendering images and something intensive geometric modeling from nothing today for the lab exercise number 4 until you get the model, okay? A sort of office interior design model. So this one includes both the modeling and rendering. At the end, some best render scene, photorealistic rendering supposed to be submitted. Anyway, let's get started. Before getting started, what we have been walked through, I simply listed up, okay, in this semester, in this course, CAD&graphics2. So we reviewed some theories, fundamentals, background theories about CAD and graphics, simply because the course title is CAD&graphics2, okay? So we have reviewed a bunch of behind the technologies in terms of theory. That's mostly the subject for the midterm exam. Using 3D Max design, okay, 2015, and mental ray. Next week's lab exercise is going to be something comparison between mental ray and V-ray. So you're going to learn what to do, how can make some visualizations using both V-ray and mental ray. But anyway, renderers, okay? And also geometric modeling, mostly for architectural modeling, building modeling, simply because we are working for interior architecture design, okay? So we have been walked through this part. But probably you may, hopefully, you may be interested what's the next, okay? Simply say something elaborated and very highly skillful CAD and graphics techniques. Simply say photorealistic rendering or some geometric modeling and easy, quick, efficient, and effective visualization technique. That's what you need to get, okay? Using 3D Max or Rhino, SketchUp, mental ray, V-ray, whatever, okay? Something elaborated, skillful techniques. And also, we need to learn something even more smart ways to geometric model or visualization and so on. So today's lecture slide, I'm going to show you one type of preview demonstration using Revit. Revit is one of the famous applications within building information modeling tools. And next semester in the digital design course, you're going to learn Revit-based BIM modeling for interior architect design and some other type of building designs and analysis. But anyway, our subject is still in geometric modeling and visualization, but we are going to preview some part of it, okay, today. For the final term project, the same slides from the last week, okay? So the description and the DA's official posters, announcements, and their descriptions, some example award winners, and image-based representation, some details. And again, our focus, our subject for the final, exactly same to the category here. Digital architecture presentation, which means you can submit just one single page, kind of best shot, or even animation. Next step to next week, you're gonna learn animation making using 3D Max. Very intuitive and powerful. Anyway, something creative, even if it's based on your studio work. So more descriptions and examples, example websites. You have to refer to those award winners, good designs, experts' work, or something professionals, visualizations. Okay. As an extension of idea development, I like to some series of more examples regarding idea development issues for your final project and something concept development for your design representation, okay? So I brought this book 2 weeks ago. Let's take a look at some more examples under the category of those geometric shapes, okay? The first one, probably the geometric shape category is tower. But anyway, some sort of commonly found tower or something unique shape tower building because of this structure and some similar structure on lower level structures. But anyway, in terms of visualization, we can figure out the entire overall shape and geometry of this building. But it's not easy to figure out what's the design intent when you see this kind of 3D render image. But this kind of 2D diagramming simply explains you what's the concept for this structure, okay? Something from cloud and something ground level, leaves, trees, plus something urban views, sightseeing. They can be geometrically combined in a certain point. So anyway, even if it's not that straightforward or easy to acquire the meaning, but at least we can simply match the geometric shape for this structure from their own design concept. So this kind of visualization, even if it's one single page, simply transfers the idea, okay? Next one, Zoomlion headquarters, single tower plaza, whatever it is, anyway, you can find out tower building and some extruded, some non-uniform shaped geometry. You can easily find out from this 3D render image, as well as this kind of top view. But actually this is 3D render shot of top view, okay? That's why we can easily generate those shadow castings. But anyway, the form of this geometry is kind of complicated. This is different design alternative, but main concept is something similar. The tower connected bridge to other buildings or other structure. Their shape is different, but anyway, in this case, floor plan or some line drawings are not that useful in terms of visualization. So that's why only 3D render images in several different views displayed, represented in this way. Okay, that's the intent for design representation for this building. Let's take a look at this one. Rock Magneton. Architect name is MVRDB. Do you know MVRDB? Have you heard before? MVRDB is one of the famous contemporary architect group. Okay, so anyway, for Denmark somewhere, they visualized this design. But let's take a look at the building shape. This one must be under the category box, right? Because this is box shape, right? But if this box shape has very typical building facade or building skin envelope structure, it's not that unique. But take a look. Thanks to this kind of 3D visualization, we can figure out very patternized and something ordered and designed building facade structure, as well as this concept combined diagram explains you how this box shape could be formed according to surrounding environments. Okay. So next case, also another type of box shape, but interesting. Let's take a look at this interior scene. When you see this interior scene, at least you can figure out interior wall surface or ceiling surface material looking totally unique. But it's not easy to figure out how or why this shape could be formed. But this exterior view, we can figure out some void spaces below. And this isometric line drawing in 2D, but anyway, 3D representation simply explains you there was a Boolean operation. Okay, Boolean operation simply means A minus B. So box minus this some round shape groups geometry in order to create final output in this shape, in this form. Okay, that's the the power of this kind of diagramming. Okay, to display and to describe what's the concept and its development before getting this kind of output, final image, final design. This kind of approach really effective and powerful. That's what you need. Pop-up hotel. Pink Cloud is also another contemporary famous architect group. Anyway, another box-shaped building. But they maximize the geometric shape of the box using this kind of module system. So let's take a look at these 18-wheelers. 18-wheelers means a truck which has 18 wheels, okay, for containers. One single container can be subdivided in this geometric shape. And this geometric shape can be easily transformed or transported or assigned to specific space. So take a look at this building facade. Also same proportional rectangle shape. And the concept, anyway, from this kind of geometric shape development, okay, thanks to that diagram. Even if it looks complicated and it's not easy to figure out what's the meaning for that, but at least in terms of visualization effect, visual effect, we can find out rectangle shape maximized the building surface, facade, building skin, front windows, as well as their sort of module system. Another module system named Instant House, and its subtitle is Instant Lung. You know what's lung, right? Lung cancer because of smoke. Anyway, Instant House, if you see this number, 2 people. So some structure for 2 people and probably 4 people. But anyway, in terms of its section profile, section drawing, we can easily find out it has some air fluid dynamic looking arrows representation and people's movement and some other structures and so on. Okay, so that's why simply why this is long. Okay, it has a circulation of airflow, circulation of some specific system, or even by human. Okay. Next case, actually we reviewed this one before last week, so let's skip. Next case is Busan Opera House. Another type of box-shaped geometry. If this box-shaped geometry has only one single unique feature, this one, media wall, that's not that unique design, just box-shaped building. Box-shaped building is the most efficient building type, okay, compared to diagonal shape or some rounded or non-uniform shapes. Anyway, box shape, the most efficient and most commonly found geometric shape of the building. But this one has media wall. That's another unique feature. But the most unique feature can be found for passengers, visitors of this building, for the bottom side of this structure. As you assume, of course, the geometry of this one from visual. This is the locality of this building is Busan, okay? City of harbors. So lots of visitors, and visitors kind of connection to the ocean, water. It has this kind of shape. And also amount of containers transporting visitors. So the box shape can be sustained by this visual structure. And it's going to be represented in this way. I think it's kind of over-conceptual, I think. But anyway, some stacked containers, structures, going to be upper part of box-shaped geometry to explain their elegant or well-defined concept. But anyway, we don't need to find out the detailed meaning. At least we can easily, visually recognize their concept and their form development method. Iceberg, next case. When you see this building shape, we can easily find out this one is kind of triangular shape, diagonal shape building. And even building facade also has same structure, triangular shape. What is it? How to generate this one? When you see this sort of infographic, take a look, this rectangle shape, another rectangle shape, but this rectangle shape can be cut by this geometry, and they will be standing 90 degrees in different direction in order to shape this form. Also, the top view has same structure, triangular shape, segment subdivision in order to allocate those building structure. So some detailed diagram I enlarged here, so you can figure out how this triangular shape can be formed, okay? Originally from this block box, but they can be forming this entire geometry. Next case, take a look at this building. Really typical and kind of boring style of geometry. But actually interior of this building, inside of this building space, looking something active and special because of this open to below, huge open to below space. Anyway, even if final output geometry is looking simple triangular shape, that triangular shape can be transformed originally from rectangle shape because of some external force or some compass, suns, whatever, okay? Take a look at this rectangle shape. You can rotate inside circle rectangle or outside the circle rectangle, only 45 degrees. And then you can easily get this kind of structure. Of course, this structure, subdivided method, very simple and primitive approach. But anyway, at the end, the effect of this geometric shape can be applied for special structure, space allocation, and so on, interaction between people, and so on. Diagram simply explains how this shape can be formed as well as something more about design. Next case, I think this case is a really good example for visually effective and architecturally also very powerful. Take a look, a mosque for all. Mosque is sort of religional building, okay, like church. So if you see this 3D render scene, kind of rectangle shaped building, that's it. But it's subdivided. And you can find out this space. This one is looking indoor, but of course, obviously, it's outdoor. You can find out outdoor space like this way. But take a look this really simple diagram in black and white line drawing. Take a look this one. This is typical shape of mosque, okay? But inverse way, you can make building shape totally different, inverse way, in order to make the same geometry in outdoor space. This is outdoor, obviously, but totally same effect of indoor of this mosque space, but easily bring the people inside of this structure, okay? So this rectangle shape overlapped two rectangle shape generates that kind of overall structure, and this inverse relationship between very simple mosque shape elevation. So in 3D, at the final design shape, you can find out that one could be easily generated. Okay, so far we have walked through some examples in 3D design representation using idea design books. Now we're going to review some 3D modeling and design representation issues, what we have learned, okay? This is kind of typical style of plans, okay? Front, left, top, right, bottom view. But actually, they are not just simple plans. I drew this one in AutoCAD 3D mode in order to generate those orthogonal views, extraction without any additional efforts. Simply, we can extract those views, okay? They are not drawings, they are views, simply because we created this computational model. So in 3D perspective view, hidden line removal view, you can easily recognize the entire shape of this chair, okay? Even if it's not easy to acquire the shape of this chair in these views. Anyway, thanks to 3D surface model, if you have this 3D surface model, entire rest of plans drawings are the subject of extraction. You can easily extract those views from this 3D model, okay? That's my point. And also 3D solid model. So simply subdivided two categories, 2D drafting, 2D drawings, and 3D modeling. We have been walked through 3D modeling part. So when you need 2D plans, orthogonal views, sometimes isometric, axonometric, perspective, renderings, they are one type of views from this 3D model, okay? So in terms of CAD history, we still in this second stage, okay? But next semester, we're gonna move entire rest of stages. Solid modeling, parametric modeling, and BIM modeling. 3D software interface. As you see here, 3D Max, what we have learned and used for the lab exercises, too much complicate. Really messy. Too many buttons, icons. No one knows what to do when they see this kind of structure at first. But we know GUI interface fundamentals and the relationship between CLI, GUI, NUI. And we usually think 3D modeling and visualization applications are really hard to learn. And now we know the reason why, okay? Ideal 3D making method is something intuitive and natural user interface. But in real world, we still need to type the dimensions, command lines, mostly based upon GUI, really messy GUI. So the gap between those two makes us hard to get 3D graphics. That's why we have reviewed something advanced geometry acquisition method, such as point cloud, laser scanners, as well as this kind of image-based geometric form generation, data acquisition, geometry acquisition, okay? But actually, real reason why 3D graphics software is too hard to learn, simply described here, okay? This is my major point in our design computing class or digital design course. Ray tracing, global illumination, so-called GI, or final gather, FG, we are using in 3D Max Mental Ray, UV mapping, polygon mesh, number of segments, number of polygons, camera lens, focal distance. All those background theories or techniques that you need to take care of, okay? Without understanding what are these, learning 3D Max, learning SketchUp, learning Rhino is simply same to memorizing the order of clicking buttons, okay, in message UI interface. What if newer version of same software released and different GUI? You have to learn again and again, even if same applications. So if you understand the logic rather than the order of clicking buttons, you can learn any complicated 3D geometric tools. What you need to do is simply Google it, YouTube tutorial, to get used for the user interface, okay? That's it. And then you can learn in a couple of hours after take a look some user interface issues, and then you can do anything else. Geometric creation, modification, 3D rendering, photorealistic rendering, and so on. So geometric modeling, if you want to create something from this kind of primitive box shape, you have to control vertices, edges, faces, polygons in editable poly or some 3D Max interface things. Create an object, modify again and again in a long time, really time consuming. This one can be converted to very complicated shape building, okay? But anyway, it's time consuming. That's why we have walked through, there are a bunch of primitives, and the 3D making methods are not that many. Representatively, extrusion is one of the important things. Lathing, revolving, another type of form creation. Sweeping, section profile, and the path definition. Even more ways, scanning, Boolean operation, something morphing, and this kind of union, intersection, plus minus, operation-based geometric shape forming. That's what we have learned, okay? But actually there are a bunch of more advanced ways, much better way, okay? My point is there are a bunch of more better ways we have. So one of the representative thing is building information modeling. Actually, I showed you before as a demonstration. Let's take a look at Autodesk Revit interface quickly, just for your information, and try to figure out what are the differences between geometric 3D modeling and this kind of modeling. This kind of modeling means building information modeling, okay? So building information modeling handles this part, also include other parts. Okay, this is Revit 2016. Revit 2016 startup page, and let's take a look at this interface. When you see this interface, you can find out there is wall, door, window, component, column, floor, railing, stairs. There is no line, point, box, cone, or sphere, okay? Modeling walls, columns, doors, spaces, floors, not points, lines, surfaces, okay? In other words, if you use this application, you cannot design game characters. You cannot design some jewelry design or automobile. What you can do for this one is only building design, okay? But if you use 3D Max, SketchUp, you can design automobile, okay? You can design drone, you can design monitors, you can draw anything, okay? Game characters, including buildings, building interior, and so on. But this is building information modeling specific modeler and analyzer, also renderer. So this one has building components. Designing a building object based on several predefined object families. This means that the columns component, they are all real-world object, okay? If you want to create 1 millimeter thickness wall, there is no such way, okay? Simply because in real world, there is no 1 millimeter thickness concrete wall, okay? Only standardized thickness, height walls can be defined. Of course, you can manually modify them, but it's going to be a problem. And this application knows that wall is too thin. It's not possible. That's problem. And alerts you. Okay, that's the difference. Also, each object's geometry is parametrically editable. You don't need to control lines, vertices, polygons. What you need to do is control thickness, height, width, depth, and so on. Okay. And entire objects have their own relationship to other objects, which means that if you want to create a door object, you have to create wall first, okay? Simply because without walls, there is no way to stand a door object, okay? How about windows object? Window object also mandatorily requires walls, okay? And actually they're supposed to be opening, and then that opening going to be filled with doors or windows. That's fundamental architectural mechanism. This application explicitly knows that. So your design could be very realistic, okay? So in this interface, looking very simple and easy to use, but not true. Really complicated. But it's dynamic and smart. In other words, if you click door object, some door-related amount of sub-options can be displayed, okay? Simply because this computer knows now you are working for door object. If you select wall, the wall-related options or some details going to be displayed, and you can do something. In this case, you can find out some mirror, move, offset, copy, and so on. Okay. Anyway, this is the interface of Revit. Lots of useful and powerful functions defined, and your views can be displayed like this: external 3D view, internal 3D view section views, or something different interior views in terms of architectural visualization method. But anyway, really powerful and our domain-specific application. Even if this is not the subject for this semester, I'd like to show you later some demos. And next semester, when you learn Revit or BIM approaches, probably your graduation exhibition or competition work going to be done by this kind of BIM tools. Simply because much powerful, easy, and time saving, okay? You don't need to spend your night times for handling editable polys, okay? Creating this kind of model, really easy and fast. So let's take a look at some little bit more details, okay? In this kind of application, there is no way to save the file for this geometry, simply because this is not geometric modeling tool. This is building modeling tool. So this one has project, okay? you need to load project, open project, or save new project. Project simply means your building project, okay? Building exterior, interior, or several buildings, campus project. Anyway, it's building construction project, okay? Or you can say just building design project. Anyway, in metric format units, and we can use template and try to model. Firstly, door object. Doors, the same style, the door object in 3D Max, you can easily generate doors. But if you create doors, this application, this Revit understands you are working with wall. So this one has properties, okay? Basic wall, generic 200 millimeter thickness, and their constraints and options, architectural standpoint. If you are working with door object, simply Revit recognizes its floor plan view supposed to be like this, okay? Even if 3D view mode, door is closed like this, but anyway, in terms of 2D drafting, 2D drawings, this door should be represented in this way. That's the architectural convention, and Revit understood that manner. That's why it can display like this way. What you need to change this door, simply change dimension or change type, style, and so on. If you want to change double flush door, simply drag and change door type in order to change this door in this way, okay? At the same time, 3D model, 2D drafting, drawings, they all synced, okay? If you update this one, 3D also auto-updated. If you update in 3D view mode, 2D drawing automatically updated, okay? No duplicated, no waste time. Also window object, in the same way, if you are working with window object, some architecturally precisely defined dimensions can be controlled and placed like this way. Also, stairwell. Similar to 3D Max stairwell, but this one is really much powerful and kind of precise, okay? Because this is parametric modeling. So when you are working with this kind of stairwell object, Revit knows the bottom slab should touch the end edge of this stairwell, and the top end of this stairwell should be touching upper level slab, okay? That's kind of parametric definition and constraint. So that's why I'm saying this is even advanced and smart way of modeling. Of course, there are a bunch of more components. Actually, this is Revit term component, but under the component, we can find out furniture desk, this kind of cabinet, entertainment center, chairs, and so on. But they are kind of default. But if your project uses this kind of Herman Miller's official workstation, this is Herman Miller website. They provide a lot of their official release of Revit model, okay? Revit family file you can download from this website. What you need to do is download this one and load your project. And then entire 3D model, cost information, material mapping, texture map, its dimension, all predefined. What you need to do is where to place this workstation in terms of your layout design, okay? You don't need to control the size of this leg, length of, depth of the table, height, and so on. They all predefined, well-defined objects, family, okay? More components from internet, which means this kind of several vendors providers have their own interface, websites for downloading components, okay? At this time, Herman Miller furniture. But if you need some lighting system, mechanical system, or some interior structure, also you can download simply like 3D warehouse. But it's totally different. 3D warehouse model, they are something existing or something virtual designed by many people, but those libraries, the name for this one is library, okay? BIM library, Revit library. They are all from real vendors, real providers, manufacturers, designers, okay? For real world project, for building. So let's take a look at floor object. Floor object means physically slab object, okay? But in terms of space object, it's conceptual, okay? Conceptual area for the floor, okay? Anyway, you can define by this one in elevation, level 1, level 2, and define slab like this way. So defining slab and interior walls and exterior walls, doors, windows, and so on, this kind of geometric model comparatively easily and quickly you can generate, okay? So based upon the elevation structure using specific floor height, you can select entire one single object to copy in smart way, okay? So-called smart copy. So smart copy object to different level using some options, and then you can easily make different floors using same structure. At the end, you can smart copy and smart edit based upon the levels. Double click level 1 and adjust, modify level 1 structure, and you can change the level 1 structure for exterior doors and so on. But anyway, this kind of building easily created from level 1 through level basement floor through the roof level, okay? Based upon this kind of interface and the function. When you see this kind of application, this one is very good for geometric modeling or information modeling for the building, but this one also has very powerful visualization features. As an example, this is simple render scene of Revit. Entire object you can find out in this room. The table, that's the library, one of the library on the component. This is this lighting stand, also one of the component. Windows too. Even this top downlight, also lighting object. What you need to do is just place using ceiling plan, and then this product has its own light intensity. So when you render it, this one can be controlling the environment brightness in automation. And also another render scene example using that Revit model. But usually for much better visualization, you can model by Revit and you can render by 3D Max. Okay, usually you need to assign new material or new texture, but actually you don't need to, because Autodesk Revit, Autodesk 3D Max, they also commonly share Autodesk material. In other words, if you model in Revit, that object's still available in mental way, Autodesk material in 3D Max. So what you need to do is control some brighter lighting system or some other visual effects things, and then you can get this kind of render scene, okay? Faster and better. Here is an example, render visualization in Revit. Revit geometric model view and its render scene. Another case, Revit's render for this dining room, and another render scene. Entire object in this scene, even this candle is the candle object, candle component in Revit, okay? That's the difference. But anyway, you can visualize this scene without controlling polygons or some other geometric things. That's the point. But actually, actually we need to go back to geometric modeling, geometric 3D modeling, okay? So-called surface-based 3D model. Because our focus sometimes only for visualization and concept development, not real construction sometimes. So for design visualization, we still need to use surface-based 3D modeling. This means we don't need to build entire exterior wall or structural things, mechanical systems, when you are working for some decorations or some special locations, layouts, and so on. So let's take a look at, quickly look at an example of 3D Max modeling and visualization. In terms of geometric modeling, no need to be a smart model when you try to visualize something, okay? So here is my scenario, a workspace on office design, concept development using 3D Max visualization. In this case, we don't need to build the entire building. What you need to do is only interior space. We can easily create a box shape and get into inside of that box. That's it, okay? And modify the box shape. Okay, in terms of scenario, defining UOD and our office interior, geometric modeling for universe environment, at this time you're going to use box shape and some design elements we can download or easily create by 3D geometric modeling method in 3D Max. So entire environment and design elements can be defined and rendering using mental ray or even V-ray, lightings, camera, material, texture, and so on. At the end, retouching in Photoshop in order to visualize maximized visual effect, okay? So let's take a look at an example concept development. The concept is media wall office, okay? Media wall, media post. Something like this NASDAQ building or sequence of screens and amount of information walls, media walls, okay? So it's a small IT company, web-based development. They need frequent feedback from websites, Facebook. So build the entire media screen for the office, even columns. So that's the concept, something like this, okay? Media projected screens or displays. So columns can be found in this way as a decorative objects, elements, and screens. You can find out something similar to this one. So in terms of modeling, the first stage, defining environment. At this time, just box shape geometry. Create a box, editable poly, and remove one side walls, and flip, installing photometric lights, and placing a camera for visualize interior scene. You should use wide lens for this camera in order to make your scene spatial, okay? Very deep. So target camera and adjust camera location and options, and placing and model some columns, posts, and some detailed features, elements, and sometimes some workstation layouts you need, okay? And then you can visualize some interior scene very quickly, okay, for your design concept. Thanks to editable poly, you can make entire middle side of those facing walls. Using texture map, you can visualize them as screen, okay? So without texture map or some additional features, anyway, we can visualize this kind of interior scene and try to make some different polygon edits and some detailed features, assigning material, texture map, floor material, material for walls or some other places, test texture map, at the end, the last texture map scenes, and appropriate stone material as well as some media post-looking texture map. So this is the final image, okay, for this very simple concept development using 3D Max, using 3D surface-based model, okay. So this kind of visualization at the end, I'm going to show you under the lab exercise folder. In number 4, under the render scene, take a look, this one. The image size for this final render is 3840 by 2160. Really high definition, high resolution. So you can find out this scene. Even if you zoom in the scene, very high definition, high resolution image. So this one may take 3 hours, 4 hours for your computers. But one of the subject for the lab exercise today is reducing render time, maximum 50%, okay? So if this one takes 2 hours, you can render this scene in 1 hour, just 1 hour, if you walk through today's lab exercise. And another case, something totally different. This one or something totally different and something even better ones are the subject for your today's lab exercise number 4, okay? We have enough time, so I think you can finish up everything in the class hours and submit something much better than this one, okay? As well as some others. We're going to deal with something similar to this one today. Anyway, okay, let's get started the lab exercises, okay?